And
that's your answer. So these are equivalent.
okay.
So the idea is that 3/9 is the same as 1/3 is the same as 6/18.
Okay.
So let's look at number 2. Very similar. Number 2 here. We're going to reduce. So is there a number that goes into both 2 and 10?
2.
So you divide both of these by 2.
2, 1/5.
Okay. So that's 1/5. And that's your first one.
Okay.
The next one is I don't want to say this. It's the we want to get larger. I don't really like that term, but you can take the fraction and you can multiply it by really anything, but why not just choose a small number like 2?
Okay. And that would be 2 or 4/20.
That's right.
4/20.
That's right.
And the next one is 1/7. So
You got it.
1/7.
You got it.
And
so again, like I don't try to make it very complicated. I would just multiply by 2. You could also multiply the new one by 2. That would also do it.
It's 6/42.
Yeah. Again, kind of a little odd that they're doing it this way, but that maybe there's something
Yeah.
How about number 4?
4.
Is there a number that goes into both 3 and 18?
No, not that I can think of. I mean, 3 can't go into 8.
So 18, right? You got to add up the digits. 1 plus 8. What does that add up to?
9. So 3 goes into that. So then 3 would work?
Yes, 3 does work.
And that is 1/9.
Try again. 18 divided by 3. So the alternative way of looking at it is 3 times what number gets you to 18?
Oh, 1/6.
6. Very good. And again, you can actually multiply this base one by something. You don't have to go back to the original. You could multiply this one, for example, by 2. That would give you 2/12. Make sure you circle or identify very clearly your equivalent fractions. In fact, your teacher might want you to do something like I wrote up here at the top, where they're sort of all together. I don't know. You could refer to your class notes.
Okay. And the other one to make it larger would be multiplying it by 2, and that is
Which one are you working on now? Still on 4 or 5?
I'm working on making 4 larger. And it's 6/36.
Yeah, that definitely works. You're making more work for yourself by choosing the original, but that's okay. It's good practice. Just keep in mind that you could go to that reduced one as well. Whenever you're ready, let's look at number
3 to go into that.
Yes, 3 goes into both of those.
And then that is 4/5.
All right.
So 4/5. And then multiply that by 2 and 24/30. So
Okay.
24/30.
That's true. Yep. Good. Let's keep going here.
Okay.
Number 6.
That 2 can go into that. That is 2/5. So 2/5. And 8/20.
Okay. All right, let's move on to number 9.
What?
Let's move on to number 9.
Okay.
Because I think you've got those down.
Yep.
So number 9 here, snip this in. Bunch of ways to do this. There's ways you will learn later, potentially in math, but for right now, you have to ask yourself, what do you multiply 7 by to get to 35?
Okay, so 7 times what is 35? That's 7 times 5.
That's right. Now, if you're really struggling, it's the same as 35 divided by 7 equals 5. Okay. Now, in the other position, because it doesn't always have to be the top, you do the same thing. You multiply 3 by 5.
And that's
What is 3 times 5?
15,
So x equals 15 in this case.
okay.
So the key is to look for the ones that are bottoms, same bottom or same top, and figure out what do you multiply by to get there. Now you can actually go either direction. Okay, so we'll see that in number 10 here. So number 10, you go from see how there's a number in both the tops? You go from the smaller to the larger here.
Okay.
1 times 6 is 6, okay?
So
But
48.
So now now I'm going to clear this out. How do you go the other direction? How do you undo multiplication?
Division.
You divide by 6. So now x, you're going to also
Divide by
x,
6.
you're going to divide
So
48 by 6.
divided by 6 is number. Can't think of it. I don't even know 48 goes into 6.
It does. It does.
Okay.
So the way you check for 6, the rule for 6 is it has to be divisible by 2, and it's even, so that's check. And it has to be divisible by 3. So 4 plus 8 is 12, which is divisible by 3. So this is just a multiplication table rule. It's 8.
Okay.
Right. So this one question to you is, how do you go from 2 to 28? What do you multiply 2 by to get to 28?
You can multiply it by 14.
Okay. So now you take the 5 and you multiply it by
14.
14.
5 times 14 is 70.
Okay. X is 70, I agree. All right. Number 12 here. Same thing for number 12. You got to like the hardest part, I guess, is to figure out are you going, which direction are you going? So if you look at it as, oh, how do I go from 3 to 18? That's multiplication by 3. We really, though, want to go the other direction, because see how we've got to manipulate 12 to go the other direction. So it's got to be in the direction of the variable here. So here
Yep.
you divide by 6.
Okay, 18 divided by 6. Okay, so 12. What divided? So 12 divided by 6. Okay, so 12 divided by 6 is 2.
There's 2. So x equals 2. So whenever you're ready, I'd like you to try 13 on your own, please.
Okay. Would it be 6?
So yes, the answer is 6. To go from 7 to 21, you multiplied by 3. So you do the same thing here. Yes, the answer is 6. Good.
I did the other way. I divided 7, which is 3.
So that's true, but remember, we're going from the number to the variable.
Oh yeah,
So
that would be
what,
multiplication.
like, your answer is fine, because I think you know how to like flip the operation, but just keep in mind, I know it's kind of confusing. Like, when does it multiply? When does it divide? You gotta just case by case here. Try not to get caught up in the rules too much. Okay, 14 through 20 are reduce. So let's do 18 next, because this is something new that you haven't seen yet. The other ones are kind of like the ones you've already done. So is there a number that goes into both 12 and 16?
No.
Are they both even?
Yes, so 2 would go in.
So 2 goes in. So you divide by 2, you divide by 2. And 6 over 8.
Okay.
There's this sort of parallel to life here, which is,
well, I mean, 8 times 2 is 16, and 6 times 2 is 12. So
well, I was going to say, you can actually keep going here, and so you divide both these by 2.
3 over 4.
Yes. And so the idea is you keep trying the number until it doesn't work anymore. And the parallel to life is we generally try something until it doesn't work anymore. All right, so let's look at 19. It's really similar. Maybe you could try this one on your own.
Okay. Two over 14. Reduce 2. 1 over 7.
That's right. You divide both of them by 2. You get 2 over 14. 1 over 7. Yeah. Good.
And then 20 is.
Let's keep going. Yeah.
1/2.
20 is 1/2. Very good. All right. So let's look at some of the area problems.
Okay.
Mixed review. Mixed practice. Okay. So do you remember any of the formulas for
The area. So would it be 4 times 4
Well, let's go by shapes that you
divided by
got on this.
2?
So if it's a square or it's a rectangle,
Isn't that a formula? Okay.
it's base times height.
Okay.
If it's a triangle, it's 1/2 base times height. So it's really
Okay.
similar.
So what you could do is base times height divided by 2.
Exactly. So yeah, to answer your question, the first one, area is
4
base
times
times height.
4.
But there's a little added answer here. It's 4 times 4, which is 16, but you need your units
16 centimeters
squared.
squared. Okay.
Or squared centimeters. Your units are super important.
Okay. And then same thing, 6 times 16 divided by 2 is 8 centimeters square.
Yes. So the area is 4 times 4 divided by 2, 8 centimeters squared. So what I'd like you to do is keep working on the rest here and just give me your answer each time. And
Okay.
I'll just
So the next
confirm.
one would be 10 times 20.
That's right.
Okay. 10 times 20. 200. $200 square for number
Good.
3.
Good. Keep going.
100 feet squared for
Good.
number 4.
Okay. Got a couple more here to do. Let's get going on the
35 inches squared.
okay. Good.
24 yards square.
Okay. And the last two.
30 meters square.
Perfect.
And
yep.
75 miles squared.
Perfect. Yeah. All right. Let's go back to 7 and 8.
Okay.
And if you, just as a reminder for 7, you do have to write 2 equivalent fractions. I want you to reduce this.
Oh, I just did the 2. I've done 7 and 8.
Oh, nice.
The ones that I haven't done are 14, 15, 16, and 17. Those are just the ones that I have.
Oh, okay. Let's go do this. All right. So these are pretty fast too. So 14, you just are finding numbers that go into both the numerator and the denominator.
Okay. 2 can go in.
Okay. So what is your reduced fraction?
1/4.
All right. So let's look at the next 3. I guess just keep working on them.
Okay. 15. Yep. For number 15, I guess 2 can't go into both.
Just 3 go
3
into both.
can't go in to 10.
How about
5
5?
can go into them. So
Yeah.
5 is 2/3.
Good.
And then the next one, 2 can go into them, which is 3/10.
Try again.
Sorry, 3/15.
Good. Now 3 does not work.
Huh?
But I'm sorry, 2 does not work, but 3 now goes into both of these.
So.
And there's a reason you start in this ascending order with the 2, 3, and the 5.
Okay. And then that is 1 over, okay. And then for 17, 2 can go into that, and that is 3 over 7, and 7's prime set, so that won't work. So that's what I got.
All right. Great job. We're all done. I mean, we've done everything. I don't think there's anything else here to cover, so we can actually just stop right here.